Hi there, and welcome to my YouTube channel, the place where I break down the concepts of chemistry into the simplest bits and pieces possible. Today, we're beginning an entirely new series, How to Balance Chemical Equations, and we're going to be taking this step by step. It's going to be a combination of a number of videos, each one that takes care of a particular aspect of the entire topic. So I want you to sit back, relax, and enjoy every bit of what I've got for you because trust me, it's going to be a roller coaster ride all through this series. Let's get into what we have. So I'm beginning this topic by asking a question. Have you ever watched someone bake a cake before? Now, if you have, you know that a number of things go into the process of baking a cake. You have a recipe, and that recipe tells you what should go into the process. You have your flour, you have your sugar, you have your milk, you have your butter, and a whole lot of other things that go into the process of baking a cake. Now, why did I use this scenario to illustrate what I want to explain? Well, chemistry is much like that, very similar. In chemistry, before new substances are formed, there are a number of starting materials, or allow me to call them, there are a number of ingredients that must be combined in order to form a new substance. Now, in the process of baking, you use a recipe to show the process of baking, the amount of ingredients that were added, and what you produced. In chemistry, we do not use recipes. We use something called a chemical equation to show the process through which new things are formed. So, what exactly is a chemical equation? You might be asking at this point. Well, a chemical equation is a short way that chemists use to show a chemical reaction using symbols and formula. We're going to be learning each of these words and what they mean. So instead of writing long sentences, okay, like water is produced when you react hydrogen and oxygen, it takes a lot of time and effort to write all of these down and can be very exhausting. So a chemist would typically use symbols. So you can see I've used the symbol for hydrogen, oxygen to denote a chemical reaction that is taking place to form water. It doesn't take as much time and it is way easier. So instead of writing long sentences, chemists used chemical equation to quickly show the substances that are reacting and the new substances that are formed. Now, the example that I just showed now showed hydrogen H2 reacting with oxygen O2 to produce water H2O. Now you can see on the left side of the chemical equation the substances that are reacting, which are hydrogen and oxygen, and on the right side you can see the substance that is being formed, which is water. So basically, that is what a chemical equation is all about, the short form of denoting chemical reactions that are happening. Now, to further explain in a way that you can understand, a chemical equation is like a cooking recipe. It's like a cooking recipe that we started with. Imagine, for instance, you want to make some fried rice and you do not know how to make it. The first thing you need to do is get the recipe for fried rice. Now, that recipe tells you the things that will be added, the time at which they will be added, the amount that will be added, and what you need to do after adding each ingredient. So you combine rice, you combine oil, you combine some vegetables, you combine seasoning, you combine meat, and after a certain process of cooking, you end up with the final product that we know as fried rice. Now, this was able to be produced because of the recipe. In the same way, in chemistry, new substances can be produced because of chemical reactions. And those reactions are represented using something called a chemical equation. I hope it's very clear to you now. So a chemical equation is very much like a cooking recipe. Now in chemistry, the starting materials or the things that you begin with, they are called the reactants and the final result is called the product. So when we were talking about the concept of baking a cake, we talked about the ingredients that you begin with. You began with milk, you began with butter, you began with sugar, and a host of other things. In chemistry, when we begin a chemical reaction, the materials that we begin with, those starting materials, they are called the reactants, and the final result is called the product. Again, the example that I stated earlier on, hydrogen reacting with oxygen to form water. These on the left hand side of the equation is called or are called the reactants, and on the right hand side of the equation we have the product, and it is represented fully well by a chemical equation. So you can see understanding this gives you a very good sounding board to begin from. So reactants are the substances that you start with. They are found on the left hand side of the arrow of a chemical equation. So here's what a chemical equation looks like. Hydrogen reacting with oxygen to produce water, the reactants on the left hand side, and the product on the right hand side. We're going to be seeing the different parts of a chemical equation to know what they mean, each and every one of them. So what does the arrow mean? This arrow that is found in a chemical equation, well, that arrow simply signifies changes into or produces. So when you see an arrow in a chemical equation, what this arrow is simply telling you is that the combination of these two elements or these two substances changes into or produces what you have on the right hand side, which is water. So if I were to read this chemical equation in words, it would simply be hydrogen reacts with oxygen to produce water. You can see hydrogen over here reacting with oxygen. This plus sign simply means reacts with or combines with, and then this arrow here means produces, and then we have water on the right hand side of the equation. I hope you're getting massive value for this. If you are, please consider subscribing, liking this video, and sharing so you can get more of this as we proceed. Now, at this point, some of you might be asking the question, why do chemists write chemical equation? Well, imagine this. I tried to write a chemical reaction using the words hydrogen reacts with oxygen to produce water, and you can see how long the process took. It can be very long, it can be very tiring, it can be very burdensome. So, chemists use chemical equation to make communication faster, shorter, clearer, and universal. So when you use chemical equations instead of words to denote chemical reactions, you are making your communication faster, making it shorter, making it clearer, and making it universal. In other words, you are avoiding the stress of going through the long route. So here are some important things to remember. This is an introductory video into the concept of balancing chemical equations. A chemical equation first shows a chemical reaction. It uses symbols and formula, and then thirdly it shows the reactants and the products. So at this point I believe very strongly that you now know what a chemical equation is and you're ready for what next we have coming for you. So reactants are the starting substances, other things to remember, and they stay on the left hand side of the equation. The products are the new substances formed and they stay on the right hand side of the equation. We saw that through the introductory part of this video. The arrow in a chemical equation simply means produces or changes into. Produces or changes into. And then here's a quick practice I'd like you to try out your hands on while we await the second video that will be coming up shortly. Identify the reactants and the products in this equation. So we have this chemical equation on the screen right now. I'd like you to go ahead and identify which one is the reactant and which one is the products. Drop your answers in the comment section and I'll be willing to give a response to that to know if you're correct or if you could use some help. It's been an amazing time with you guys on this introductory video. I enjoyed it just as much as you did. Up next, we're talking about why balancing chemical equations matter.